Assalamu alaikum. My name is Khairullah Khaliq and I am a student of BS Computer Science at Quaid-i-Azam University, Islamabad. Today I will be presenting my research work paper AI model for IoT attack detection using machine learning algorithms. This project focuses on solving a very real and growing problems detecting cyber attacks on smart devices. I will explain step by step how we can use machine learning algorithms to detect these threats and how effective our model was. This slide outlines the flow of my presentation. I will walk you through an introduction to IoT and the issue of security and the application of IoT in real life, a literature review to understand what work has been done before, a problem statement to highlight what is still missing. Our proposed solution using machine learning algorithms, the results in comparison from our experiment, a discussion to interrupt the findings, a conclusion to summarize everything, and finally the reference we used. So, introduction, what is IoT? IoT is the Internet of Things. These are the smart devices like cameras, light bulbs, and sensors that connect to the internet. And the more IoT devices we use, the more vulnerable we become to cyber attacks. This is because most IoT devices have weak security and can't run antivirus software. To solve this issue, our project uses AI models, especially machine learning algorithms, to automatically detect when an IoT device is under attack. So talking about the applications are smart homes like smart bulbs and security cameras and healthcare, heart monitor and smart cities like traffic systems and street light and talking about the banking and finance and they are using a secure online systems and ATMs and industry machines in factories that are monitored remotely. So in this slide literature view we will talk about the past works on IoT devices. The researchers used random forest decision tree based method and achieve around 85.34 accuracy. Others tried SMB, KNN and logistic regression, but these models often fail to detect rare or new types of attacks, so they weren't reliable enough for real-world systems. So researchers also use advanced method to improve CNN, a convolutional neural network. It is great for pattern recognition, and LSTM, long short-term memory. It is a model work well with time-based data like network traffic. And some researchers build a fake IoT environments using a Raspberry Pi. And the CICIoT dataset used in this machine learning algorithm to detect. It is created to simulate real attack traffic in IoT networks. These three methods improve result, but they still had some challenges. So what are the challenges and issues in past work? First we have the problem imbalance dataset. For example, it is a more dataset like CICIoT 2023. There are thousands of records for common attacks like DDoS, but only a few hundred records for rare attacks like SQL injection. This imbalance creates a big issue. The machine learning models become biased, and it learns to detect only the frequent attacks and misses the rare but dangerous one. Second, many models lack of proper integration of deep learning techniques. Deep learning models like CNN and LSTM are very powerful, especially for recognizing complex patterns in network traffic. The third one, the models were often not tested in real-time environment. In the real world, IoT attacks happen live and second by second. Many past methods were trained on old and static datasets and not evaluated under real-time or higher speed conditions, which makes them less useful in practice. So in this research, the researchers focused on solving four key problems found in the earlier models. The first one is imbalanced dataset. Models are often perform poorly on rare attacks, like SQL injection, because most of the data is from common attacks like DDoS. The second one is limited detection scope. Many models only detect one or two attacks. And the third one is outdated and synthetic dataset. Some studies use non-realistic data, which reduces reliability in real-world data use. And the fourth one is lack of scalability. Complex models are often too heavy for real IoT devices, which have limited resources. And our goal was to build model that is accurate, scalable, and tested on real-world data to overcome all these issues. So to address the problems identified earlier, the researchers designed a supervised machine learning based detection model that can classify different types of IoT network traffic as their normal and malicious. So the researchers use CICIoT2023 Dataset, which contains 2,21,834 records. This dataset includes 6 traffic classes, which are DDoS, rise, spoofing, and etc. You can see in this slide. We choose 4 machine learning algorithms for comparisons. The first one is DT, and the second was NB, and the third one is LR, and the last one is SMV. So a decision tree is a simple and interpretable good with imbalanced data, and the nearby is fast and based on the probability, and the logistic regression good for binary and multi-class classification. And the last one, sport vector machine, it is very powerful and to solve complex discussion problems. For implementation, we use Python in the Google Colab along with libraries like pandas and numpy, etc. So this approach allowed us to evaluate the performance for different models on real-world data using standard machine learning algorithms, tools, and techniques. So in this slide, the researchers use CIC dataset, Canadian Institute for Cybersecurity. It shows that the dataset is imbalanced, meaning some attacks types have a lot of data like DDoS, while others have a very little like SQL injection. So they classify the data table IoT attack classes and collected from these classes the data. In this slide, we will explain the architecture of our attack detection system. We can explain this step by step. It shows how we collect the data, processed it, and applied machine learning models and evaluated their performance. So first is dataset input. We started by loading the CICI dataset, which is in the form of CSV format. This dataset includes labeled traffic data, where each row represents a network record and it is marked as either normal or one of the 6 attack types. The second one is data processing. Next, we clean the dataset to remove missing values or irrelevant features. And then we use PCA to reduce the number of features from our 80 to 42 important ones, which makes training faster and most accurate. And third, we can train and split the data set. After pre-processing, we split the dataset into 80 training data and 20% for testing data. Then we move to the model training. We train 4 machine learning models, and these was TT, NB, logistic regression, and SMV. Each model learned to classify network traffic based on the features provided. Then we move lastly to the model evaluation. After training, we tested each model on the 20% testing data, which evaluated performance using matrices like accuracy, confusion, metrics, and visual graph that you will see in the next few slides. So in summary, this architecture outlines the full journey from raw data to pre-processing to training to evaluation, make it easy to understand how the model works end to end. So what is the setup? As we discussed in the previous slide, that first we have to split the dataset into 2 parts. The first one is training and the second is testing. Then we will extract the features using PCA, and then accuracy and confusion metrics used for evaluations. Then we will implement this in Python with default parameters. This is the performance result using machine learning algorithms. The top accuracy is 98.34, that is decision tree, and LR, which is have a 75%, and SMB, which have split into 2 remarks with default hyperparameters and with sigmoid kernel, and the naive have a 92% accuracy. So this was the graph of previous table, which shows the performance result. This slide shows confusion matrices for 4 models we tested, and let me explain what these matrices tell us. A confusion matrix is a chart that shows how many predictions the model got right and how many it got wrong for each class. The diagonal values top left to bottom right represent a correct prediction. The off-diagonal values represent errors when the model predicted the wrong attack type. So these matrices help us understand not just our accuracy but how reliable each model is for every type of attack, especially the rare one like SQL injection. Now we compare our model's accuracy with results from previous research studies. So what this means, our model achieved 98.34 accuracy, which is higher than most traditional models, while one study used deep learning reached 99.4. It used a smaller and simpler dataset. Our approach is combined high accuracy with simplified, making it more practical for real IoT system. So this comparison shows that our solution is competitive, efficient, and realistic for actual use. So let's go over what we learned from the result. The decision tree was the best overall models. It had the highest accuracy and the least number of errors. It also worked well with imbalanced dataset, and talking about the naive bias was also good, but it made a few more mistakes and was a bit slower. And the third one is SMB with sigmoid had a lowest performance, especially with rare attack types. The CIC dataset helped us test on real and diverse attack data, which made our findings more reliable. Overall, our system is accurate, simple, and work well across different types of IoT attacks. Now let's conclude the presentation. Researchers built a machine learning system that detects 6 types of IoT attacks using real data. Then they tested 4 models and found that the decision tree gives the best performance with 98.34 accuracy. Then the model was handled imbalanced dataset effectively and performed well on both common and rare attacks. And the future works, they tried deep learning methods like CNN and LSTM, use larger and most recent dataset, build a real-time detection system for live IoT attacks. So this study improves that a simple and well-designed machine learning model can protect IoT devices from many serious threats. These are the two references that researchers used. These sources helped to build a strong, reliable, and real-world applicable machine learning system for IoT security. And that's it. Thank you so much for watching and listening.